2,000 feet below the surface, where sunlight dies and pressure crushes steel, something drifts through the darkness. It moves without urgency, suspended in water so starved of oxygen that most creatures would suffocate within minutes. Its body glows with an otherworldly blue light, small pinpoints of bioluminescence scattered across velvety skin the color of dried blood. 8 arms spread outward like the fingers of a ghost, connected by webbing that forms a cloak. And then, sensing danger, it does something impossible. It turns itself inside out. This is Vampire Squid, the vampire squid from hell, and it has been perfecting the art of survival in Earth's most hostile environment for over 183 million years. The story of the vampire squid begins in an ocean that no longer exists. During the early Jurassic period, when dinosaurs first dominated the land and pterosaurs ruled the skies, the seas teemed with strange cephalopods, creatures with multiple arms, internal shells, and bodies designed for predation. Fossil evidence recently discovered in Luxembourg reveals that ancient vampiromorphs were fierce hunters. Specimens like Simonite Toothus bacalii, preserved from 183 million years ago, show muscular bodies and powerful suckers, tools built for capturing prey. These early ancestors had something their modern descendants lack: aggression. But the oceans were changing. As continents shifted and climates transformed, oxygen levels in certain depths began to plummet. Areas called oxygen minimum zones developed, layers of water containing just a fraction of the oxygen found near the surface. For most creatures, these zones became death traps, but for some vampiromorphs, they became sanctuaries. The fossil record shows a dramatic shift. Analysis of a specimen called Necroteuthis hungarica from the Oligocene epoch, about 30 million years ago, reveals that by this time, vampire squids had already retreated into the bathyal depths, inhabiting environments with bottom water anoxia. This fossil, originally discovered in 1942 and thought lost during the Hungarian Revolution, bridges a staggering 120 million year gap in our understanding. It tells us that the transformation from aggressive predator to deep-sea scavenger happened gradually, driven by the development of oxygen minimum zones during the Cretaceous and early Cenozoic periods. What made them survive when so many others perished? The answer lies in their willingness to abandon everything that defined a successful cephalopod. While their relatives evolved larger sizes, faster movements, and more complex hunting strategies, the vampire squid took the opposite path. They became smaller, slower, stranger. They evolved to thrive in conditions that would kill almost anything else. Today's vampire squid is a living fossil, virtually unchanged for millions of years, a creature that evolution decided didn't need improvement. An adult reaches only about 11 inches in length, roughly the size and shape of a football. Its gelatinous body has the consistency of jellyfish, making it neutrally buoyant in water. This isn't weakness, it's genius. By filling its tissues with ammonium compounds that are lighter than seawater, the vampire squid can drift effortlessly without expending precious energy on swimming. In an environment where food is scarce and oxygen scarcer still, every calorie matters. The creature's appearance is unsettling in its beauty. Its skin shifts between velvety jet black and rusty crimson, depending on the angle of light. Though in the depths where it lives, at 2,000 to 3,000 feet down, light is a rare visitor. What appear to be 2 large fins protrude from the sides of its body like the pointed ears of a bat. Young vampire squids are born with 1 pair of fins near their eyes, but as they mature, these are absorbed and replaced by a new pair positioned for maximum swimming efficiency. It's a double metamorphosis that mirrors the creature's transformation from active jet propulsion in youth to graceful fin flapping in adulthood. But it's the eyes that command attention. Proportionately, they're the largest eyes of any animal on Earth. On a 6-inch squid, each eye measures 1 full inch in diameter, roughly the size of a full-grown dog's eye on a body no bigger than your hand. If human eyes were sized proportionally, they would be as large as soccer balls. These enormous liquid orbs appear blue or red depending on lighting conditions, and they're not just for show. The vampire squid's eyes and enlarged optic lobes are adapted to detect the faintest traces of bioluminescence from miles away, the only light that exists in the midnight zone of the ocean. 8 arms extend from its body, each lined with rows of fleshy spines called eerie that give them a thorny alien appearance. Unlike true squids, which have 10 appendages, including 2 specialized tentacles, the vampire squid has only 8 arms, but it possesses something unique: 2 long retractable sensory filaments that can extend to more than twice the creature's body length. These filaments aren't tentacles in the traditional sense. They're sensory organs covered with tiny hair-like structures that detect the slightest movements in the water. The vampire squid deploys one filament at a time, letting it drift outward like a fishing line, feeling for food particles suspended in the darkness. Between the arms stretches a webbing of skin, dark on the underside and eerily reminiscent of a vampire's cape. The inner surface is black, concealing something extraordinary: photophores. The vampire squid is almost entirely covered in light-producing organs, small white discs capable of generating bioluminescent displays that range from fractions of a second to several minutes. The largest and most complex photophores cluster at the tips of the arms and the base of the fins. The creature has precise control over these organs, modulating their intensity and duration like a conductor orchestrating a light show in the abyss. But in a place without light, what good is the ability to glow? The answer reveals one of nature's most sophisticated defense mechanisms. The vampire squid cannot change color like its shallow water cousins. Its chromatophores, the organs responsible for rapid color changes in other cephalopods, have lost the muscles that enable this ability. Color is useless in total darkness. It also lacks the ink sacs possessed by true squids and octopuses. Traditional defenses are obsolete in the oxygen minimum zone, so the vampire squid evolved something better. When threatened, it performs a transformation that seems pulled from nightmare. The arms curl upward and outward, wrapping around the body in what researchers call the pineapple posture. The webbed cape turns inside out, exposing the sharp cirri while concealing most of the body's photophores. The underside of the cape, heavily pigmented, creates a dark shell. But at the tips of the arms, visible far above where the creature's head actually is, the photophores ignite. They glow intensely like twin eyes staring from the darkness, then slowly dim, creating the illusion that the creature is swimming away. Predators strike at the glowing arm tips, missing the vital organs hidden safely below. If this light show fails, the vampire squid deploys its ultimate weapon: bioluminescent mucus. From the tips of its arms, it expels a thick, sticky cloud that glows with an eerie blue light. This isn't ink, it's far more insidious. The mucus can remain luminous for up to 10 minutes, an eternity in the deep ocean. It confuses predators, creating multiple false targets as the squid makes its escape through a series of erratic, zigzagging movements. But there's a darker purpose to this glowing slime. If the mucus touches a predator, it sticks, making that hunter glow in the darkness like a beacon. In an environment where stealth means survival, the vampire squid essentially paints a target on its attacker, exposing it to larger predators prowling the depths. It's the deep-sea equivalent of triggering a burglar alarm. The vampire squid's eyes aren't just large, they're engineered for survival. The expanded optic lobes of its brain allow it to process even the faintest bioluminescent signals across vast distances. In the featureless void of the midnight zone, this sensitivity is crucial for detecting potential mates, identifying prey aggregations, and spotting predators before they strike. Those massive eyes can track the tiny flashes of distant animals, reading the language of light that echoes through the abyss. Yet for all its defensive brilliance, the vampire squid's greatest adaptation is metabolic. It possesses the lowest mass-specific metabolic rate of any known cephalopod. Its blue blood contains hemocyanin that binds and transports oxygen with remarkable efficiency, aided by gills with an unusually large surface area. Where other creatures would suffocate, the vampire squid thrives at oxygen saturations as low as 3%, levels that would kill most complex organisms within minutes. This ability allows it to inhabit the oxygen minimum zone with virtually no competition.
Few predators can hunt here, and those that can, giant grenadiers, deep-diving whales, and sea lions, face the same oxygen constraints that the vampire squid has spent millions of years learning to overcome. But what does a creature eat in a place where almost nothing can live? For decades, scientists believed the vampire squid was a predator like its ancestors, hunting small prey in the darkness. Then, researchers at the Monterey Bay Aquarium Research Institute made a discovery that changed everything. Using remotely operated vehicles equipped with cameras, they observed vampire squids exhibiting behavior never seen before in any cephalopod. The creatures weren't hunting, they were waiting. As the vampire squid drifts through the water column, it extends one of its long sensory filaments, letting it trail outward like a sticky net. The filament collects anything that touches it, and what touches it is marine snow. This term sounds poetic, but the reality is less romantic. Marine snow consists of dead plankton, fecal pellets, abandoned larvacean houses, crustacean molts, dead diatoms, and mucus. It's the constant shower of organic debris that drifts down from the sunlit waters above, feeding the entire deep-sea ecosystem. Most of it is waste. Some call it marine snot.
The vampire squid is the only known cephalopod that feeds exclusively on detritus. It doesn't hunt living prey. When particles collect on its filament, the creature slowly retracts the appendage and uses its arms to scrape the material into its mouth, mixing it with mucus to form small balls of food. It's not glamorous, but it's sustainable. By feeding on the snow that falls through the oxygen minimum zone, the vampire squid plays a crucial role in the biological carbon pump, the process by which carbon is captured from the atmosphere and locked away in the ocean's depths, helping regulate Earth's climate. This discovery resolved mysteries about the creature's biology. Its weak musculature and gelatinous body aren't signs of evolutionary failure, they're optimizations for a low-energy lifestyle. It doesn't need powerful muscles because it's not chasing prey. Its highly developed statocyst, the organ responsible for balance, allows it to maintain position in the water column with minimal effort, descending slowly and balancing almost effortlessly. While the vampire squid can swim surprisingly fast in short bursts, reaching speeds of 2 body lengths per second within 5 seconds, it cannot sustain long migrations or extended pursuit. It doesn't need to. The food comes to it. The vampire squid's reproductive strategy reflects its deep-sea existence. Unlike many cephalopods that reproduce once and die, the vampire squid reproduces multiple times throughout its life, a strategy called iteroparity. Males transfer sperm packets to females using a specialized organ, and females store this sperm until conditions are optimal for fertilization. The eggs are relatively large, 3 to 4 millimeters in diameter, and are released directly into the water in small batches. Growth is slow as nutrients are scarce at these depths, and sexual maturity isn't reached until about 2 years of age. But here's what makes them remarkable. They can live for over 8 years, an extraordinary lifespan for a cephalopod. Most of their relatives live only 1 to 2 years, dying shortly after reproduction. The vampire squid's longevity suggests a creature so perfectly adapted to its environment that it has achieved something close to biological equilibrium. It doesn't need to evolve further. It has found its niche and claimed it completely. Recent genetic analysis has revealed something even more profound. Scientists successfully sequenced the vampire squid's genome and discovered it to be the largest cephalopod genome ever recorded, more than 11 billion base pairs, over twice the size of the biggest squid genomes. An astonishing 62% of this genome consists of repetitive elements, stretches of DNA that repeat over and over. But hidden within this genetic code is a secret: chromosomal structures that belong to both octopuses and squids. The vampire squid sits at the evolutionary crossroads between these two groups. While it's technically an octopodiform, an 8-armed creature related to octopuses, it retains parts of the chromosomal structure of its 10-armed squid relatives.
Meanwhile, studies of octopus genomes revealed that early octopuses also had squid-like chromosomal structures that compacted and fused over time through a process called fusion with mixing. The vampire squid's chromosomes, however, remained largely unchanged, even as its genome ballooned in size. This makes it a genetic Rosetta Stone, a living archive of cephalopod evolution stretching back over 300 million years, to before squids and octopuses diverged into separate lineages.
The first specimens were collected during the Valdivia expedition of 1898 to 1899, led by German zoologist Carl Chun. Inspired by the earlier Challenger expedition, Chun set out to prove that life existed in the deep ocean below 300 fathoms, about 1,800 feet, contrary to the prevailing abyssal theory, which held that no life could survive such depths. The expedition was funded by a society of German scientists who believed otherwise, and they fitted the ship Valdivia with specialized equipment for collecting deep-sea organisms, along with laboratories and specimen jars for preservation. The voyage traced a path from Hamburg to Edinburgh, down the west coast of Africa, around the southern tip of the continent, and into the depths of the Indian and Antarctic oceans. Among the bizarre creatures hauled up from the abyss was a small, dark cephalopod with a cape-like webbing and blood-red coloration. Chun initially described it as an octopus in 1903, but its unique features soon became apparent. It had characteristics of both squids and octopuses, but belonged fully to neither group. He classified it into its own family, Vampiroteuthidae, and gave it the scientific name Vampiroteuthis infernalis, vampire squid from hell. For over a century, the vampire squid remained an enigma, rarely seen and poorly understood. Specimens were difficult to study because they're injured easily during capture and rarely survive in aquariums for more than a couple of months. The Monterey Bay Aquarium Research Institute changed this through the use of remotely operated vehicles, allowing scientists to observe the creatures in their natural habitat without disturbing them. These observations reveal the true nature of the vampire squid's lifestyle and behavior, transforming our understanding from predator to peaceful scavenger. But mysteries remain. Scientists still don't fully understand the vampire squid's breeding habits or population dynamics. The vastness of its habitat and the sparse distribution of individuals mean that reproductive encounters will be rare, fortuitous events. How do they find each other in the lightless expanse? Do they communicate through bioluminescent signals? How do they navigate territories that span hundreds of vertical feet in interdimensional darkness? There are questions about their sensory capabilities. We know the retractable filaments are covered in sensory layers, but what exactly are they detecting? Can they sense chemical signals, vibrations, temperature changes? How do they distinguish edible marine snow from worthless debris? And what about their intelligence? Cephalopods are known for complex cognition, problem-solving abilities, and even elements of consciousness. What thoughts, if any, pass through the mind of a creature that spends its entire existence drifting through silent darkness, feeding on the dead remains of organisms it will never see? Recent technological advances have opened new possibilities for study. High-resolution imaging, genetic sequencing, and deep-sea robotics are allowing researchers to piece together the vampire squid story with unprecedented detail. But each answer generates new questions. Why did this lineage survive when so many others vanished? What will happen to vampire squids as climate change alters ocean chemistry and oxygen levels? Will they adapt, or are they already living at the absolute edge of biological possibility? The deep ocean is changing. Human activities are warming the seas, altering currents and expanding oxygen minimum zones in some areas while shrinking them in others. Deep-sea mining threatens to disrupt ecosystems that have remained stable for millions of years. The vampire squid, so exquisitely adapted to its narrow niche, may face challenges that evolution has not prepared it to overcome. These creatures survived the extinction event that killed the dinosaurs by retreating to the depths, but there may be no deeper place to hide.
When you look at the vampire squid, you're looking at time itself, a living connection to oceans that existed before humans, before mammals, before the continents took their current shape. It has watched entire lineages of creatures rise and fall. It has outlasted countless species that were faster, stronger, more aggressive. Its survival strategy is patience, efficiency, and the willingness to thrive where nothing else can. There's something profoundly unsettling about a creature that turns itself inside out to survive, that feeds on death, that glows in the dark not for communication but for deception. The vampire squid embodies the alien nature of the deep ocean, a reminder that Earth contains environments as strange as any imagined planet orbiting a distant star. It lives in water so cold it's just above freezing, under pressure that would crush human bones, in darkness so complete that light itself becomes a weapon and a tool. Yet there's also something beautiful in its existence. The vampire squid doesn't fight, it doesn't dominate, it simply endures. In a world of predators and prey, of competition and conflict, it has chosen a different path. It waits in the silence, collecting the fragments that fall from above, glowing softly in the dark, a blood-red cloak drifting through an eternal night.
The vampire squid asks us to reconsider what we mean by survival, by success, by evolution itself. It reminds us that sometimes the most advanced adaptations look like simplifications, that sometimes the key to thriving is not to become stronger, but to become more efficient, that sometimes the way to survive impossible odds is not to fight them, but to embrace them completely. 2,000 feet below the surface, where sunlight cannot reach and oxygen cannot sustain most life, the vampire squid continues its ancient vigil. It has been here since the Jurassic, and if the oceans allow it, it will be here long after we're gone. A living fossil, a genetic time capsule, a ghost wrapped in a blood-red cloak, glowing softly in the abyss, feeding on the dead, turning itself inside out when threatened, existing in perfect balance with a world that seems designed to make existence impossible. And in that darkness, in that silence, in that crushing pressure and suffocating scarcity of oxygen, the vampire squid reminds us of a truth that most of us spend our lives trying to forget. The universe is vast, and we understand almost nothing about it. The deep ocean covers most of our planet, yet we've explored less than 5% of it. What else is down there? What other creatures have been perfecting their survival strategies since before our ancestors climbed down from the trees? The blood-red cloak continues its eternal dance through the abyss, a reminder that the most alien creatures on Earth don't come from space, they come from the depths. And they're watching us with eyes the size of soccer balls, glowing softly in the dark, surviving where nothing else can, waiting with infinite patience for whatever comes next. Somewhere in the midnight zone right now, a vampire squid is drifting through the darkness, its enormous eyes scanning for the faintest trace of light, its sensory filament extended like a blind man's cane, collecting the snow that falls endlessly from the world above. It has no idea it's being studied, no awareness that humans are obsessed with understanding its secrets. It simply exists, as it has existed for 183 million years, doing what evolution designed it to do, surviving in hell. And perhaps that's the most profound lesson the vampire squid has to teach us. Hell isn't a place of fire and brimstone. Hell is the oxygen minimum zone at 2,000 feet, where most life cannot exist, where pressure is crushing and darkness is absolute. And if you're adapted for it, if you're willing to become something strange and patient and efficient, hell can become home. The blood-red cloak continues its eternal dance through the abyss, a reminder that the most alien creatures on Earth don't come from space, they come from the depths. And they're watching us with eyes the size of soccer balls, glowing softly in the dark, surviving where nothing else can, waiting with infinite patience for whatever comes next.